Hello everyone and welcome to Bruin Academy. I hope you've been finding these resources helpful so far in studying for Chem 14A. So this first video is going to cover some of the foundational concepts you absolutely need to know before you get to the more difficult stuff. So while this information is not necessarily high yield or test level material, you really have to know it, right? It's important to start with the basics before you get to the stuff that's super important. So this right here is just a snapshot of what I'll be covering in this video. So let's just go ahead and get started. Okay, so let's start with chemistry. So chemistry really is the study of matter and the chemical reactions that occur between substances. And matter is made up of atoms, okay? So atom is the basic unit of matter. So what is an atom made of, right? So an atom is made up of three particles: the electron, which is negatively charged, the proton, which is positively charged, and the neutron, which is neutral, has no charge at all. And the nucleus, which is the center of the atom, is composed only of protons and neutrons with electrons orbiting. Okay, so a few important terms you should know. The first is atomic number, all right? So what is atomic number? Atomic number just refers to the number of protons. So it's how many protons you have in the nucleus. The mass number is the sum of the number of protons and the neutrons. So this is often called, another name for mass number is actually nuclear mass, right? Because basically it's the mass of the nucleus, right? It's only protons and neutrons which are in the nucleus, okay? So it's the mass of the nucleus. Okay, so this right here is sort of a convention you should be familiar with when you do some practice problems. So the first is, there's an A, X, and Z. So what do these represent? So first, the X just represents the element name. So for instance, helium, carbon, nitrogen, etc. A up here always represents the mass number. So this is the number of protons and neutrons. Z represents the number of protons, the atomic number. So naturally, okay, you can figure out the number of neutrons by taking the mass number minus the atomic number, and that will get you the number of neutrons. So let's look at a quick example. So let's say we have, that symbol notation for carbon, right? We have carbon 14, mass number, and 6 is the atomic number. So we call this carbon 14. 14 just refers to the number of neutrons. So based on this information, let's figure this out. So how many protons are here, right? Well, carbon always has 6 carbons no matter what. We look at the Z, which is 6, so the number of protons is going to be 6. The number of neutrons, as I mentioned before, is the mass number, which is 14, minus the atomic number, which is 6. So 14 minus 6 is going to get us 8. Okay, so very basic stuff. Foundational concepts, as I mentioned before. You should be familiar with what makes up an atom and this notation as well as these definitions. Okay, so a few other important definitions. So first, ions, and then next will be isotopes. So think of ions and isotopes as different forms of the same element. So it's the same element, just something's altered about it, okay? So in ions, the thing that's different is the number of electrons, okay? So it's the number of electrons, okay? Everything else is the same. So the number of protons is the same, number of neutrons is the same, only difference is the number of electrons. So as such, they differ in electric charge, right? So there's two types of ions. It can either be a cation or an anion, okay? So you can either gain electrons or lose electrons. So a cation is positively charged, and so for something to be a cation, it needs to have lost electrons. So cations lose electrons, right? So if something loses electrons, then it's positively charged. Conversely, an anion gains electrons, right? So anions gain electrons, right? And because they have additional things that are negatively charged, right, which are electrons, they are negatively charged overall, okay? So this is kind of intuitive, but an anion, which gains something, gains electrons, is bigger than a cation of the same element, right? When you're comparing similar elements, anion is always bigger than a cation, which makes sense. Okay, so that's an ion. An isotope is similar, but instead of differing in the number of electrons, they differ in the number of neutrons. All right, so as I mentioned before, everything else is the same. So number of protons is the same, number of electrons is the same. The only thing that's different is neutrons. So they differ in the mass number, which, as I mentioned before, is the sum of protons and neutrons. So let's look at a quick example down here, right? So these are two different isotopes of oxygen. On the left, you have oxygen 16, and on the right, you have oxygen 18, right? And where this number represents the mass number, Okay, so here the number of protons, number of electrons is the same. The only difference is the number of neutrons, right? 8 versus 10. That's an example of an isotope. All right, so important to keep in mind is the periodic table. You will be seeing this all the time in your chemistry course, I guarantee it, and you'll be using it all the time, especially for 14A. All right, so every element is defined by the number of protons, okay? And in total, there are 118 elements, so a bunch of them. If you count them all, there's 118 of them, some more common than others. So as I mentioned before, defined by Z, by the atomic number. So for instance, if, an element has 2 protons, right? So this number in the top left corner represents number of protons, so that's the atomic number. If it has 2, it's always going to be helium. If it has 6 protons, it's going to be carbon, etc. Okay? So there's 2 important numbers that always appear in the periodic table. The first is atomic number, and the second is this number that's often a decimal, and that refers to the molar mass. Okay? So you can think of the molar mass as sort of a weighted average. Okay? So the molar mass is a weighted average of, so I'll call this weighted average of the mass number. So weighted average of the mass number. So again, I mentioned that the mass number is the sum of the protons and neutrons. The molar mass is just of all the helium atoms that exist in the world. Most of them, on average, have an atomic, a mass number or atomic mass of about 4.0026. Okay, so it's just an average of everything that exists in the world. Okay, another thing that's important to keep in mind for the periodic table is that elements in the same column, which we call this a group, okay, so vertical columns are groups. Elements in the same group have similar chemical properties. So they have similar properties, always, okay? So it's the elements in the same column that have similar properties, not elements in the same row, all right? So for instance, everything in this left column is a metal, with the exception of hydrogen, and they're very unstable, okay? So that's group 1. Whereas if you look at the right-hand side, which is group 8, these are the noble gases, right? And they're very stable, okay? And then the things in the middle right here, these are transition metals, and they all share similar properties, all right? You'll notice here that there are 3 different groups in the periodic table, right? So these are going to be metals, metalloids, and nonmetals. So nonmetals generally appear on the right side of the periodic table, and the one exception is hydrogen, which is on the left. Sort of in this middle area, you see mainly metals, and these tend to be conductors of electricity, whereas nonmetals don't conduct electricity very well. And metalloids are they form this staircase in between, and these have properties of both metals and nonmetals. Okay, so atoms bonded together form compounds, right? And there's 2 types of compounds. The first is molecular, and the second is ionic. So let's talk about molecular compounds first. So molecular compounds form when you have a nonmetal bonded with another nonmetal, okay? And these atoms in a molecular compound are connected with a special type of bond called a covalent bond. So it's always a covalent bond, okay? And in covalent bonds, very important, electrons are shared, okay? They're not transferred. They're shared by the 2 atoms, okay? And so whenever there's any sharing, the electrons can either be shared equally or unequally, okay? So if they're shared equally, this only happens when the 2 elements are exactly identical, okay? So like O bonded to another O, or C bonded to another C. This is called a non-polar covalent bond because it's equal sharing. If it's shared unequally, meaning there's 2 different elements bonded to each other, for instance, a C bonded to an O or an N bonded to a C, you have a polar bond, okay, a polar covalent bond. Okay, so examples of some molecular compounds you see, some are very common. So for instance, water, H2O, right? 2 nonmetals bonded to each other via covalent bonds. Maybe another one is CO2, right? Carbon dioxide, what we exhale all the time, okay? So examples of molecular compounds. Ionic compounds are a bit different, okay? So ionic compounds involve a metal and a nonmetal bonded to each other. Okay, and these guys are bonded with what are called ionic bonds, okay, which are different from covalent bonds. And in an ionic bond, electrons are transferred from one element to another, okay? And usually what happens is the metal ends up transferring an electron to the nonmetal. So the metal loses an electron and it becomes positively charged. It becomes a cation. The nonmetal gains an electron, so it becomes negatively charged and it becomes an anion. Terms that I mentioned before. Very important to remember. So some examples of ionic compounds include table salt, which is sodium, right, bonded to chlorine via an ionic bond. You could even have potassium chloride, right? Pretty much anything from a metal bonded to a nonmetal, that's an example of an ionic compound.